Hi guys, good morning. Today we are going to continue kind of in this sort of all been a chapter with everything we did last week. Um, you can go ahead and you can entitle today's lesson Reaction Types. All right, Reaction Types. And today is Tuesday, May 26th. All right. We're not going to go quite in depth as we would if we were in the classroom. So here we go. There are 5 different styles of reactions. So when I look at a word equation, I'm able to analyze it and I'm able to determine which 5 types of reactions you're going to see. And there are little tricks for each one. So I'm going to introduce them to you today. All right. So the first type of reaction, sorry, the first type of reaction is what we call synthesis. So when you're synthesizing something, when you're synthesizing a piece of information or even photosynthesis, you're putting things together and you're getting one thing. So synthesis is 2 or more things. Well, it's not 2, so it's 2 or more reactants. Those are our things. Yielding one product. So when I said, I wrote that in capital letters because each reaction type is going to have kind of like a key thing, like one thing you're really going to look for. Synthesis has the general equation, A plus B. So there are my 2 or more reactants right there, yielding one product. So it's going to be 2 or more reactants yielding one product. And this is what you're going to look for. One thing on this side. There's no plus something else. It doesn't exist in a synthesis reaction. So what's an example of synthesis? An example of synthesis, let's say, I don't know, maybe you like to put salt on your French fries, all right? So we're going to take sodium plus diatomic chlorine, and we're going to get table salt, all right? So I have my 2 things combining and yielding one product. Okay, so that's an example of synthesis. 2 or more things combining to form one product. All right, the next style of reaction is the opposite of synthesis. The opposite of synthesis, we're not putting something together. Now we're going to break it down. So the opposite of synthesis, if you're not putting something together, you're breaking it down, is decomposition. All right, so this is the breaking down of one reactant to form 2 or more products. Okay, so it's the breaking down of one single reactant that's going to form 2 or more products. Okay, so we can write this as the opposite. Here's my one reactant. That's my key word. It's going to form 2 or more products. Okay. So you can have, I'm trying to think of a decomposition reaction. You can decompose water into its 2 gases. So I can decompose water. There's my one reactant. And I can break it down into two or more products. All right. So synthesis and decomposition are opposites of each other. So reaction types 1 and 2 are opposites of each other. Next, our next reaction type is something called a single replacement. All right. So in a single replacement, the word single means one. So one element is going to switch with another in a compound. Okay. So one element is going to switch, take the place of another. It's going to kick it out in a compound. This could be an example of, I don't know, maybe you're playing soccer, volleyball, basketball, any game, lacrosse, any sport that requires a sub. All right. One person subs in, so therefore one person subs out. Okay. That's what a single replacement reaction is. So this is its general form. A plus, I'm just using random letters, BX. All right, yields. Well, in a single replacement reaction, what's my single thing? It's A. It's going to come in and it's going to kick out the cation. It's going to kick out the first thing in a reaction. So let's go through and let's just analyze this really quick. A is always going to be an element, or there's always going to be an element plus a compound, yielding a single element plus a compound. All right, so you can also think of single as like a single element. So what does this look like in reaction forms? All right, so maybe it looks like this, Na plus KBr. All right, so my Na, this is my single element, and KBr, this is my compound. So this guy is going to kick out the K. Right, it's going to sub in the game. So now K is by itself, and Na is paired up with bromine. So do you see how that works? It kicks out the first thing. It's going to kick out the cation. Okay, so the cations, the first thing in the compound, replace. So I have one single thing kicking it out. And then, so on this side, I have my single element plus my compound. Okay. That's single. And remember, you can pause these videos. You can go back and rewatch these videos. And I'm going to post more tomorrow. All right. The next type of reaction is a double replacement. All right. So in a single reaction, one thing substituted in. In a double reaction, the two cations in compounds will switch. Okay, so the two cations in the compounds will switch. So the general form of this looks like AB, there's one compound, plus, let's put XY, there's my other compound. Yields, well, the cations are going to switch. So A is now going to be with Y, X is now going to be with B. Notice a couple things. If it's written first, it has to stay being written first. If it's written second, it has to stay being written second. These are all things that you already know. but you may not know how to apply them to this lesson. So AB is a compound. XY is a compound. And it yields 2 compounds on this side. All right. So what does this look like in a reaction form? Well, in a reaction form, let's have 1 compound. Let's just keep using salt. And we can use KBr from the last one. All right. So it states that the 2 cations will switch. So this is the first one written. This is the second one written. They're going to switch spots. So K is now going to be with Cl, and Na is now going to be with Br. I didn't write any subscripts because everything I'm choosing had a charge of 1, either 1 plus or 1 minus. So I don't have to do any crisscrossing. I can just cancel out with these. So in analyzing this, NaCl is a compound. KBr is a compound. We got compound, and we got compound. All right. So single replacement and double replacement, the biggest difference is in a single replacement, this guy right here, that's going to be an element, and that's going to be an element. Everyone every year always goes, so if it's a lot of letters, it's a double. Well, most of the time, but you have to make sure that you have 2 compounds. All right, and our last one, this was always my favorite to do because this is where we would set stuff on fire, is combustion. So when you think of combustion, you always think of something maybe catching on fire. So this is true. You're going to take a gas and you're going to set it on fire. So there are a couple things that need to occur for that fire to take place. All right, so for a combustion reaction, there has to be a couple of things that take place. And a combustion reaction is really going to look the same. You need something to catch fire. And that is a specific thing. It's what we call a hydrocarbon gas. And in order for a fire to occur, you need to feed it with oxygen. So those are your 2 reactants. A fire is always going to produce what 2 things? It's going to produce smoke in the form of carbon dioxide. Oops, hold on. Let me write out the word. Carbon dioxide. And it's always going to produce water vapor. So these 3 parts will always be the same. And the thing that's going to change is the hydrocarbon gas. So maybe you cooked out this weekend and you used a gas grill that had propane. All these hydrocarbon gases are going to end in ane. Methane, ethane, propane, butane, pentane, octane. And they're highly flammable. So propane is C3, I think H6. So that's my hydrocarbon. It's kind of written backwards. Here's your hydro, and here's your carbon. So it's a hydrocarbon plus oxygen is going to be O2 because it's diatomic, yielding carbon dioxide and water. Okay. Next, maybe you're working with in a lab, or maybe you have a butane lighter that you use to light a grill. Butane is C4H8. So the only thing changing are these little subscripts down here. All right, oxygen is still needed to support a fire. It's always going to produce smoke. It's always going to produce water. Okay, so those are the 5 reaction types. We'll do a little bit more with them tomorrow. But for today, I just want you to take down the notes. Thanks.